Hello,
Hello, Linda. Welcome.
welcome.
My name is Amanpreet Kaur, and I work at DBP Institute as business analyst. So I'll be the host tonight. And yeah, welcome. How are you doing today?
I'm doing just great.
Okay, so let's wait for other people to join in, and then we'll start. Like we'll just wait for a couple of minutes, maybe 3-4 minutes, and then maybe we'll start. Okay.
Okay, I need to share my screen,
Uh,
or do you have things you want to share first?
Yeah, I have like few slides, like 4-5 slides, which I'll share first, and then maybe you can share. Pavna, can you allow the sharing?
Yes, Aman, yes, I have allowed the sharing,
Okay.
multiple sharing.
Yeah. Hi,
Hi,
Ryan.
Amin. Hi, Linda. I'm Ryan.
Hi.
Nice to meet you.
Hi, Ryan. Welcome.
Thank you. Thank you. Good to be here. Where are you sitting, Linda? Where are you in the world?
I am sitting in Montauk, Texas, which
Oh, right on.
is about an hour and a half north and slightly west of Fort Worth.
Okay, there you go. And how's the weather today?
Beautiful, gorgeous. About 72 degrees, bright sunny day.
It's like every day in Texas.
Well, no, but yes.
Excellent.
We do get cold, and we're far enough north. I'm only 10 miles, from the border with Oklahoma. So if the jet stream is correct, then we get snow here.
Gotcha. Really? Wow, I wouldn't have thought so, but cool.
Usually about an inch or two every other year.
Yeah.
But the maximum we've ever gotten since we've been here is 15 inches.
Okay.
But
That's a lot.
That beat the all-time record, which the previous record was 5 inches.
Yeah.
That was a really weird year.
Yeah, substantially. Excellent. Well, thanks so much for your time today. And yeah, really looking forward to hearing the talk.
Great.
Software metrics.
Now, I have not done a Zoom where I was the presenter. I've attended many Zooms, but I may stumble just slightly as I am putting the slides up.
All good. We'll walk you through it. We'll help you through it.
I've been using GoToWebinar, GoToTraining for like 15 years or more. So
yeah,
it's not like I'm not used to doing this. In fact, this is my third webinar this week.
You're on the webinar circuit.
Well, I usually do one every week for my Software Excellence Academy.
Yeah.
But last week I got stuck on the road with a broken tire rim. And we had to order it, so I didn't get back in time. So I postponed that one till Monday.
Right.
This week. So I did one on Monday and Wednesday, which is my normal day. And then, oh my gosh, I forgot. I got this one too.
Yeah, it's crazy. Just some of the weeks, I feel like some of the weeks during COVID have been, like you say, just 3 in a week. It's all packed up. And then your next week, you'll be sitting there going, well, like I got nobody to see, or you got like maybe 2 or something like that. And you kind of feel like it's up and down. And if you're never really leaving the house a lot, it's been weird. It's going to be an adjustment going back to offices.
Yeah, well, this is my office. So,
yeah.
I mean, I work out of the house except for when I'm on the road. But yes, not being on the road has been interesting. I had 18 weeks on a road scheduled before COVID started. I was working mid-January clear through April.
Yeah.
And then COVID came and everything got canceled. I managed to get through 7 weeks of it before everything else was canceled.
Yeah, wow.
So I'm used to being on the road all the time because I do training in all of these software engineering topics.
Gotcha.
That's what I do is I go to companies and teach their people requirements and quality and testing and auditing and all of those. I call it the donut, everything but design and code, because that's, that is so dependent on what you're doing and how you're doing it and what languages you're using.
Right.
But the fundamental testing principles, auditing principles are the same no matter what you're teaching.
Okay. Excellent. Well, yeah, I'm fascinated to hear about what this is and what you're doing.
Well, I've actually specialized in software metrics for the last, gosh, almost 30 years.
Okay.
I started my own company 21 years ago, but before that, I spent 12 years, well, I guess it's almost 34 now, 12 years being the manager of quality metrics and analysis for a large telecommunications company.
Oh, yeah.
And we did all the metrics. We took all the data and turned it into metrics for all the managers, not only in software, but in hardware, in training, in customer service. We did
Wow.
metrics for the whole company using my basic 12-step process
So
that I put
you have an
together back
idea of
when.
everything,
Mhm.
right? For all the way from, plugging it into the wall to what happens now and everything. You've seen it all.
Oh yeah, writing all the SQL to extract it out of all the corporate databases and.
Beautiful.
Yeah. But I've been in software for 45 years now, slightly more.
Okay.
Yeah, I used to program, but the very first computer I touched with my own hands had 8 toggle switches, 8-bit machine, one for up, one up for 1 and down for 0. And you literally set those 8 toggle switches and pushed a button to load the instruction, and set the next 8 toggle switches and pushed a button to load the
Oh
next
my.
instruction. And if you loaded all 100 and some bootstrap instructions correctly, it would read the paper tape operating system into the computer.
Jeez.
And it had 120 baud. Notice there's no K's in there, let alone gigs or megs or anything. 120 baud teletype machine. And you actually typed onto a roll of paper.
Right. Okay.
Yeah, I'm pre-WYSIWYG.
Well,
Do you even know what WYSIWYG means? You're so young.
No, I don't know. I haven't heard that one. I remember using a typewriter once.
WYSIWYG means what you see is what you get.
Gotcha.
So the more modern word processors, when they first came out, what you saw on the screen was actually how it was going to look when you printed it. That's WYSIWYG. Versus when you had to embed all, wanted something bold, you embedded codes on either side of it to make it bold in between the codes.
Right. I think the earliest memory I have is of course, the green screen Macintoshes to learn how to type in grade school. And then Dad brought home, I think what were they called? A 286?
Yep.
Yeah, I remember he brought home a 286 at one point, and you had to type in all the commands to even to start the thing up. You almost had to know how to code. And there was
you got a greater than sign on the screen, and that was your prompt.
Yeah.
All you got is a little green. Yeah. I always jokingly say, but it's true. If you want to see the computers I used to work on, go to the Smithsonian Institute.
Yeah.
They are actually on display there.
Well, computers we worked on, 5 years ago are in the Smithsonian these days. So
yeah, true.
Yeah, wouldn't feel too bad about it.
Yeah, my first full-time job as a software engineer, I shared a mini computer with 7 other people. We each got 1 hour of computer time a day.
What were you supposed to output in an hour?
Well, that's when you did your compiling and your testing. You actually wrote your code on coding sheets, paper coding sheets, and handed them in to the key punch operators.
Oh, man.
And they would give you a deck of cards that you would hand back in with JCL slapped on the front, and then you got a tape. And then the teletype machines had a little reader that would read the tape. We used to patch programs by splicing paper tape together. I was very good at it.
No way. Oh,
okay,
man.
with no further ado, let's start.
See you after the thing.
I think let's start because it's already 10 minutes up. So
Absolutely.
welcome everyone today for joining in for today's webinar, which is conducted by DBP Institute. Today we have Linda Westfall with us from Team Westfall. And before giving her introduction, let me take you through a quick overview of what DBP Institute is and what do we do. Sorry. So our vision is to be the first option for businesses to create their digital future. We want to be a respected firm that provides best of breed digital data and analytics solutions. We believe in our core SPICE values, which is simplicity in the way we work, that is being humble, the passion for the work that we have and for our clients, integrity in the work that which we do, committed to the work, committed to the project, and finally excellence, delivering excellent quality solutions to our clients. So how do we do it? We do it by providing consulting and education. So here you can see our 12 main consulting domains in digital data and analytics. And as you can see, which is like self-explanatory, we need systems to have digital solutions, the data to run, which is fuel for technology. And finally, we have to get the insights, we have analytics as well. So we provide training services as well. We have four main training domains, which is done mainly in UFC, IE Business School, and some online webinars, which are somewhere vary from 8 to 10 hours uh, per webinar. And for our partners are basically SAS for analytics and machine learning, GrihaSoft for master data cleansing, Evaluaserve for analytics research and strategy, Modoc for data integration and engineering. So why companies should hire us? And there are three main reasons for that. In most places, it's not just about solving the problem, it's also about identifying them. Key problems and solving them is our main motto. We identify solutions which has maximum leverage or return on investment for our clients, and we help our clients to find innovative ways to deliver value for a very low cost, which is excellence. So today's webinar is sponsored by two companies, that is Intellergy and Tech.com. And now let me introduce you to our speaker tonight, which is who is Linda Westfall. And she has over 10 years of, 40 years of experience in the software industry, delivering excellence. Linda is currently the president for Westfall Tech and a software excellence strategist. The Westfall team provides software engineering, quality, and project management training and consulting services. She is the author of Certified Software Quality Engineering Handbook. She will be talking about effective software metrics for digital transformation. Thank you, Linda. Over to you.
Okay, now I have to figure out how to share my screen, so give me just a second.
Yeah, you can see a green button at the bottom,
Yes.
saying share screen. And then you might have a couple of windows up. Perfect.
Okay, well, hopefully you've got it. So what I'm going to talk about, the official title today, is how to select useful software metrics. Although this can be applied to any metrics, my expertise over the last 30 years of doing metrics is specifically in the software arena. Are you DRIP? It's a good question for you. I'm sure you don't even know what DRIP means, but I see many organizations where this cartoon is very true. Our analysis of the data that we've collected provides us with a single clear message. We're collecting far too much data. DRIP basically means you've got lots and lots of data in your organization, but you're not turning that into information that is useful to you. You're data rich and information poor. That's DRIP. So how do we go about taking all this massive amounts of data and actually doing, as she just mentioned, turning it, analyzing it, turning it into useful information that we can make better decisions on? That's the intent here, is to make good decisions about your projects, your products, your processes, your business. When I first started doing metrics over 30 years ago now, there seemed to be basically two historic schools of thought. The first school of thought was collect data on everything. There's got to be information in there somewhere. This always makes me think of the little guy with the light on his helmet, furiously digging away at the large pile of rock, trying to find that one diamond that's going to be useful, that one piece of information that answers all the questions. Or as a joke, the friend of mine told me, you've got a huge pile of manure and the little girl is furiously digging away with a shovel for the pile of horse manure. Because if there's that much horse manure around, there's got to be a pony in there somewhere. You know, we're hunting for those diamonds through all the data. Of course, the rest, that's what the big boys did. The IBMs, the AT&Ts, the Boeings, the Hewlett Packards, they collected all this data and then worked and worked and worked and worked, trying to find the meaning in it. The rest of us, the smaller companies, couldn't afford to do that. So what we did is we waited until the big boys found a diamond and wrote about it in a paper or a book, and then we went and copied it. Of course, instead of having a diamond, we ended up with a cubic zirconium. You know, it looked like a diamond, but it didn't provide us with the information that we needed to better run our companies, to make better decisions. These two approaches are what I call the Jeopardy approach to metrics or information, where you start with the answer. You all know the game Jeopardy with the late and great Alex Trebek, right? He gave you the answer and you tried to guess what the question was. So your McCabe cyclomatic complexity is 32. What? Nobody wants to jump in and buzz in and give me the question that goes with that? You know, what does it mean? Why do I need it? What information is it giving me? How do I make decisions based on that? So we had these two schools of thought. Now, why is the first school of thought, collecting data on everything, why does it not work for us? Well, first of all, metrics are expensive. It's expensive to collect the data. Your software engineers, your software testers, your project managers, your people are not there to collect data for you in many cases. They have other jobs like building software and testing software and running projects, etc. And for them to take time out to record all this data becomes an issue. It's expensive to do that. It's also expensive to even just store the data. When I worked for the telecom company, we started storing so much data that we ended up having to go buy larger and more expensive disk drives just to store it all. It was expensive to buy the tools to record it in. And it's expensive to take all this data and try and search through it to find those gems of information. The other thing that's true here is there's just so many possible measures. I'm always asked the question, what are the top 5 or the best 3 metrics? Linda, what's your favorite metric? And I always say the one that answers today's question, because tomorrow I'm going to have a different question and need a different metric to answer it. So what we're going to do here today is talk about the first 4 steps in my 12-step software metrics process. We're going to talk about the 4 steps to selecting the right metric and getting down to your metrics requirement. What are you even required to do? The other steps talk about designing and implementing that metric. But today, given that we've only got an hour, we can talk to the first 4. And it's just simply easy to drown in the enormity of the task. This is why organizations like DBP even exist, because they're going to help you do that. They have the expertise to help you get through that enormity of data, trying to turn it into useful analytics that you can use to make better decisions. Of course, then there's that random selection of metrics. According to Watts-Humphrey, there's so many possible measures in a complex software process that some random selection of metrics isn't going to give you much of value. The data you collect is always incomplete. You ended up not collecting that one additional piece of data that somebody needed, or you're collecting it inconsistently because you don't have good definitions of what that data even is, when to collect it, how to collect it, who should be collecting it, what units of measure. I mean, we can even go to the Mars lander that blew up in the atmosphere and talk about that being a measurement problem. One of the modules was made of code was measuring how many feet it was to the planet. It passed that number to another module of code that interpreted as the number of meters away from the planet. They weren't using consistent units of measure in their software. The program said, not close enough, let's get closer. And it lost $1 million mission. It's just inadequate to answer your questions, to provide you the information you need to truly manage your products, your processes, your projects. So what's the 4 steps to get past all of this? The first step is to identify the metrics customer. Who's going to use the data? Who's going to take that information and make decisions based on it? Who's actually going to use it? Because you can create the best graphs and charts and analytics in the world. If nobody uses it to make decisions, it's worthless. You've wasted your company's time and money. So you've got to identify who needs information, who's actually going to use that information. Because you've got to remember, metrics don't solve problems, people do. I've seen more than one company who has an annual goal of putting metrics in place. Wrong goal. The goal has to be to provide people with information they can use to turn it into knowledge, to turn it into wisdom, to provide people with the information they can use to make better decisions. So if your company's doing any metrics today that don't have customers, everybody looks at it and says, oh, isn't that interesting, and files it away and doesn't make a decision on it, doesn't use it, stop it. Like I said, you're wasting your time and your company's money. In fact, when I was doing metrics full-time for a job, I would once in a while, if there was a metric that I didn't think was being used, I'd just stop delivering it for a few days and see if anybody came and asked for it. Because unless it's people are actually using it, they'll let it go and never bother to come ask for it. If they're using it, they were in my office that afternoon saying, why didn't you deliver this report today? I need this to make this decision. And that's what you want happening. So for the next 3 steps, after you've identified your customer, I go back to Vic Basili and Rumbaugh and the third guy whose name I can never remember. One of the days I'm going to look it up. But I go back to the basic goal question metric paradigm. I think this is a very useful paradigm. It was created back in the 80s, and I still see books written against it today. I still teach it in all my classes. This was just a brilliant idea. And what they basically say here is once you've identified your customer, find out what their goals are. What are they trying to accomplish? What are they needing to make decisions about? And then you go to, for each of those goals, come up with a series of 1 or more questions that they need answers to get the information they need. And finally, you pick metrics, analytics to help them answer those questions. So that's the next 4 steps, folks. Step 2 is to target the goals. Now, if it's senior management that's the customer, they're going to have high-level organizational goals, like to be the low-cost provider, or to meet certain revenue or profit targets, or to be the high-quality provider of X product, whatever. So you're going to put metrics around those high-level targeted goals to answer the questions senior management has. If you're looking at the project level, projects need to know, am I going to deliver on time? Am I going to deliver on budget? Is my product of the quality level it needs to be? Have I fixed all the defects that I found? These kinds of goals. Is the project on budget, on time? Are we going to give all the functionality and all the quality desired? are we effectively and efficiently using our people and other resources? Those tend to be the goals of a project. Of course, we can go all the way down to the individual task level. I use a lot of the metrics I put together as entry criteria. Are we ready to start this process? Or exit criteria is this process complete? So we can look at things like, have we effectively inspected module ABC? That might be the goal, to do that. And we might have questions around, do we have good coverage? And then we can look at the different levels of coverage for that module. So we're looking at entry and exit criteria to individual tasks, to individual phases or iterations if you're using an agile life cycle. So there's different levels of goals. You have to identify the individual customer and then determine what their goals are. And you're going to have a lot of different metrics that target different customers. As you move through the life cycle, some metrics will go away, some metrics will come back. We had metrics that we did only during requirements. We had other metrics for design and code and testing. And then we had those project level ones that went from the start to finish of the project. Now, if you look at the practical systems and software measurements processes, they don't talk about looking for the goals. They don't use the goal question metric paradigm. What they use is the issue metric paradigm. And what they say is go find where the problem areas are and then get metrics in place that provide you information to help you solve those problems. Now, I like the goal question metric better because I, being a quality-oriented person, don't want to wait until after I have a problem to solve it. I want to make sure I'm moving towards my goals and keeping those problems from even happening, preventing those problems from happening. So I like to look at the goal question metric, but if I go to one of my metrics customers and ask them, what are your goals? Yeah, that deer in the headlight look is what I normally get from them. It's like they may or may not have any concept of their goals. But if you go ask them what's frustrating you, what's not working for you, again, your problems, you can usually get a litany on those from your customer. So I don't have any problems with starting with their frustrations, but I always want to translate those frustrations into what goals are they missing. And that's a good place to start. But then you want to start putting what I call leading indicators in place, metrics that help you predict and prevent that from ever becoming a problem. So we can eliminate those frustrations before they become frustrations. So that's why I like the goal question metric paradigm. So the first step, identify who needs the information, who wants the metrics, who are going to use the metrics to make decisions. Second, we find out what their goals are. Now, this may mean interviewing them about what their frustrations are, but then we need to work with them to translate those frustrations into what they're trying to accomplish. What are their goals? Then I do a brainstorming with those customers. And I say, what questions does that customer need answered in order to determine whether they're moving towards their goal or they've actually met it? For example, the metrics that become exit criteria from successfully completing a process. So that's the third step. Just some examples here. If I have a goal of maintaining high levels of customer satisfaction, hopefully you have a goal similar to that. Wouldn't it be useful to know what our current level of customer satisfaction even was? What attributes of our products or services are most important to our customers? Are they more interested in long-term reliability? Are they more interested in performance? Are they more interested in usability? You know, what's most important? And we would take those questions and build that into potentially a customer satisfaction survey, which gave us the data we needed to answer that first question. How do we compare with our competitors on those most important customer attributes or product attributes? We found that it was, even if we were very good, we were being scored a 4.8 out of 5 on our customer satisfaction surveys. If our competitors were 5s or 4.9s, we might still be in trouble. So we also wanted to know how our competitors were doing and what problems that we have with our products affect our customers the most. Where are they most dissatisfied? And what are the issues around that? And these are all questions that we can collect data against and then put metrics together. Another question, if you're looking at delivering on time, how do our actual progress towards completion compare with our project schedule? How much work do we still have to do? How accurate have all our estimates of effort, schedule, productivity, those predictions been so far? And what major risks stand in the place that are still in place that may cause major impacts to our ability to stay on schedule? So these are just examples of some of the questions. Whichever goal you have, you can brainstorm a set of questions to it. Pick the most important questions, start with those, or pick the most important metrics from those question sets and work with those. So now we have picked our customer, we've thought about their goals, we've talked to them about what information they need, what questions they need answered, and the fourth step of selecting metrics is determining what metrics we need to collect and produce to provide the information needed to answer those questions. Now, if you go back to the goal question metric paradigm, you'll see that for each question, we might have multiple metrics, but some metrics may answer multiple questions as well. Now, as we're selecting these metrics, you want to be pragmatic, realistic, practical. Don't try and create those ivory tower metrics. Your metrics can always become more sophisticated as your processes and your information needs become more sophisticated. You also want to consider the current engineering environment. If you have data, try and use that. In fact, at first, when we were trying to size our products, the only thing we had was the size of our executable. Was that good enough? Well, it was good enough to use as a normalizer. If this product was twice as big in bytes as this one, but had only a third of the defects, obviously this one's much higher quality than the one with a smaller size but more defects. So you can use some of those things as current data. It's good enough. You don't have to measure to the millimeter if you're miles away from your target. But as you get closer and closer and closer to your target, millimeters may be appropriate. So you can always add more factors, add more information to your metrics over time. And those are issues of design that we cover in future steps of this process. But for right now, we're just talking about selecting the right metrics. And start with what's possible, what's easy. Pick that low-hanging fruit. It's important information, but it's also easy to get, easy to turn into information products, charts, graphs, numbers, whatever, that we need to help answer our questions. So here's just an example of starting small and getting bigger. These are some metrics that we went through as we were introducing a new process. In this case, we were introducing formal inspections of our work products, where you actually have a preparation step, do the meeting, et cetera, et cetera. Hopefully you all know what a formal inspection is. If not, you can look it up. But at first, we just wanted to make sure people were doing it and starting it, and they'd been trained and that they were actually doing it. So our questions were things like, are we doing it? And we collected the number of inspections being held per week, the total amount of effort, the number of lines of code or lines of documentation that were being inspected. That was our rough size metric, and the number of defects were found. And we can do a lot with that. What are we even inspecting? We were looking at the percentage of code, the percentage of the requirements, different lists of items. How many of our design documents got looked at? How many of our pieces of code? Notice these are very high level metrics. And when were we inspecting? We were doing waterfalls, so we were looking at number of inspections per phase. If you're doing Agile, you could look at the number of inspections per iteration, whatever, just so we could start seeing, are we even doing these? Then as we got better and they were actually implemented, it was something we were doing. Now we wanted to make sure we were doing them effectively. And we took a lot of the same data, added a little bit more data to them, and started looking at things like what are our optimum parameters for an effective inspection. And we looked at defects found for things like preparation rate, how much time should we spend getting ready per size, or how much time should we spend in the meeting per size. We found out for us, we could look at between 5 and 10 pages of a requirements document per 2-hour meeting. That was our optimum to find the biggest defect density, defects per time spent. How many attendees should be in the room? We went and did a study on that with data and found out that if we were optimizing for efficiency, i.e. the most defects found per time, put 4 people in the room per effort. 4 people was the optimum. The 5th person found a few more defects, but they spent more time, more effort, than the curve started going down. If we were looking at pure effectiveness, I'm sorry, that was efficiency. Effectiveness, total defects found per time, we put 6 people in the room. And this helped us make decisions. If it was a high-risk module, we'd get 6 people to inspect it. If it was something that was safety critical or mission critical or whatever, we'd opt towards effectiveness because we wanted defects out of those. For the less risky components, something that just did a report, something goes wrong, you tear up the report, you fix the code, you rerun the report, no harm, no foul, we would put 4 people in the room. Or we might, for really low risk stuff, do a desk check or a walkthrough instead of an inspection. How well are we performing the inspections? We looked at defect rates and tracked it over various inspections to see if we had any, once we got these optimum parameters, see if anything was falling outside of that optimum that might be an issue where we need to make a decision to re-inspect that particular document. We did it too fast. We had some other issue with it. It was just too defective. It had, we also started looking at things like phase containment. How many requirements problems did we find during requirements activities? How many design problems did we find during design activities, as opposed to those escaping to later phases? And we just started looking at how well we were doing inspections. What was our defect removal effectiveness, and was it getting better over time? And then when we really started getting mature, we started looking at metrics as drivers for process improvement. Where can we get better? So we started using that phase containment to say, hey, what are we doing better? Design repair inspections or requirements inspections or code inspections? And looking at phase containment and saying, we've got a 75% code phase containment, but we've only got a 50% requirements phase containment. Therefore, we're not doing as well finding requirements defects during requirements. And we would go in and do more training. We would go in and analyze the kinds of defects that were escaping, looking at their root cause. Were they missing? Were they ambiguous? Were they poorly worded? Were they whatever? And look at improving those areas or those inspections specifically where we were not doing as well as other inspections. We're looking at what types of defects are being introduced in each phase. As we just said, was it a missing requirement or an ambiguous requirement? And we would use those as lessons learned, feeding back into additional training, additional improvement, etc. We also use this to identify high defect programs. Now you have to be careful here, folks. Everybody knows that Linda wrote that defective piece of code, but you don't want to be blaming Linda, because if you do, that's the last time you're going to get good data. People will beat the metric if they have to. So management had to be very careful about ensuring that they were looking for these as areas for improving the work product, not for blaming Linda. There may be reasons I write poor code. For example, the requirements I was handed were very bad. Or we've changed this piece of code 17 times, and every time you touch it, something goes wrong. So we were looking, again, be sure you're staying process focused and product focused when you're looking at these defects, and not trying to identify people with them. Again, it's just too complex, too multifaceted. We're looking at defect removal effectiveness. How well are our testing processes doing at removing defects before they go on to the next phase? How well are our inspection processes doing? So that we were getting better and better at doing inspections, making decisions about targeting our improvement efforts where they had the biggest bang for the buck. You can also use the goal question metric paradigm backwards to evaluate your existing metrics. If you have a current analytic, a current metric, and you're questioning, is it useful? Is it have the appropriate customers, etc.? Take that metric and ask yourself, what questions does it answer? What information does it provide to answer those questions? And then take those questions and say, what goals are they providing information for, to tell us whether we're meeting that goal or at least moving towards that goal. You may find that you have existing metrics that you're already collecting that align with more than one goal. You may have collected them for this goal, but they also apply to that goal. And if we'd have just given this second customer the same information, they would have had a lot more information to make better decisions about. So this can expand your customers. Of course, it can also tell you, do you even have a customer? Is anybody using this data? So not only should you look for different customers or additional customers for that metric, you need to verify that it even has one. And even if the current person you created it for no longer needs it or wants it, there may be somebody else that needs it or wants it. You may not want to stop it. You may just want to start propagating it elsewhere. Now, Watts-Humphrey says there's 4 reasons you ever collect data and create metrics for information, and that's to provide information for 4 reasons. The first reason is just to understand. I need to know how long it takes me to do something. I want to know how satisfied my customers are. I want to know, am I on schedule? I want to know where my error-prone components are, whatever. I'm just trying to understand. You use that as a study to identify areas where, for example, you can target your process improvements. Then I want to keep things under control. This is where I establish some kind of threshold, some kind of target range, some kind of this is good versus that's not so good. And we're making a decision about whether or not to take action. With control type metrics, you hope the answer is everything is good, it's in the green range, and we don't have to worry about it. But if it does pass the threshold, if it does go outside the range, it indicates that some kind of corrective action is necessary, potentially. Now, folks, don't ever let the metric make the decision. I have seen it where, for example, a statistical process control chart, something is outside of 3 standard deviations. That does not mean take action. It says go investigate. Because with a control metric, even if you're looking at statistical process control charts, plus or minus 3 standard deviations, you can be outside of that 1 every 1,000 times. So if you're looking at millions of opportunities, of course you're going to be outside the limit. But it does indicate that there may be an issue you need to go investigate. And the reason I bring this up is you may need additional metrics for that. one of the things that I put in place is what I call my vital sign metrics. This is what tells me my process, my product, my project is healthy. You go to the doctor, they take your vital signs, your temperature, your blood pressure. They may pull some blood and do some basic tests, gathering information. If all of those vital signs are good, you're healthy and you go home. If any of those vital signs indicate an out of control condition, then you go do additional measures, take additional blood, do additional tests, whatever, to find out why. So you may want to design and select metrics and put them in place so you're collecting the data so you can do that drill down to those additional metrics if you need them, but you don't do them on a daily, weekly, monthly basis. You also collect metrics in order to evaluate your processes, your products, your projects. This is where I'm making a choice between decisions. In control, I'm either in control and don't have to worry, or out of control and there's an issue that I have to go correct or at least investigate. With evaluate, you're trying to do a cost-benefit analysis, or you're trying to decide which areas I need to address. You're trying to make a ship, no ship decision, buy, no buy decision. You're making a choice between two alternatives or more than two alternatives, and you're trying to decide which one is the optimum. And you collect data and information, you do your analytics to provide information into doing that. For example, I may decide, is this a high risk module or not? Well, how much requirements churn has it had? How many defects has it had in the past? Things like that may be indicators to say, do a 6-person inspection versus a 4-person inspection. And then we use metrics to predict the future. This is where we're taking historic data and using it with trend lines, et cetera, to predict the future. For example, we looked at cumulative defects and we were arriving during the testing cycles, and we expected that to go flat. And as it went flat, we were projecting that the product was good enough and that it wasn't going to have very many defects once it hit production operations. So we use it to predict how good the product's going to be, how risky the product is, how much time it's going to take us to build it, how much budget it's going to take to build it, how many people do we need, et cetera, et cetera. What's its reliability, what's its usability, et cetera. So there's lots of things that we can use to predict. Typically, we take that understanding of where we are today. How much did it cost us the last time we did something similar to this? And we use that data and information to help us predict the future. Similar to the Scrum people taking the velocity over the last 6 iterations and averaging that to predict the velocity of the next iteration. So what are useful metrics? Again, I said I was going to help you select useful metrics. Useful metrics are ones that are going to help people make good decisions because it provides them objective information, facts rather than wild ass guesses or gut feel, right? To make better day-to-day decisions. Have I finished testing? Is this module good enough to move on to the next iteration of development? Should I start this process? Is it ready to start? Identifying project issues. Are we over or under budget? Are we ahead or behind schedule? Where are we effectively and efficiently using our people? Correct existing problems. Help us find those error-prone components that potentially need rework, or help us find where our processes aren't working effectively for us that we need to target. They can help us manage risks. Metrics as simple as the probability the risk turns into a problem and an estimate of the impact if it does helps us manage those risks, helps us identify the high risks that need to be mitigated. It helps evaluate the performance levels. Again, like velocity, how long is it going to take us per story point to build things? It helps us get more accurate predictions, our estimates of effort, cost, schedule. Basically, it gives us facts and information that we can use to improve our software products, processes, and services. Do I believe in metrics? Wholeheartedly. I've made it a significant part of my career. One of the quotes I love is, quality without metrics is just cheerleading. Folks, we have to move from a craft in software where we are making decisions based on gut feel or scientific wild ass guesses, swags, and start using the data that we have. Most of you probably have a lot more data than you even realize, but you're drip. You're data rich, information poor. So use some of these methods to start thinking about how I can provide better information by putting metrics in place to do the analytics. And I go back to, if you need it, there are firms like the one sponsoring this webinar today that will help you do that. I am much more focused on software development communities myself. I help them get the metrics they need to manage their software projects, software processes, software products, and not the big data stuff. I'm not into big data, but the same basic concepts apply. So now I'm going to open it up for any questions that anybody has. And here's my presenter information. Again, more than 40 years in the industry. My husband jokingly says, my goal in life is to have the entire alphabet in certifications. I'm a continuous learner, and the certifications are one way that I can get kind of credit for my learning, or it keeps me learning because I've got a goal to work towards, right? And they've already mentioned my book. And if any of you have questions after this webinar, here's my contact information. So we're going to open it up to questions. Can somebody take everybody off mute?
So anybody who is having any question, they can unmute themselves. Rest of them can stay muted and then ask question.
Either I made myself very clear or everybody's confused.
Well, I think for me, Linda, like software's, that's a very foreign concept for me. So not too many questions. I'll take your word for it on a lot of things, but I find it really interesting. And it always seems to be the same thing with metrics and analytics, is you really need to take a step back and understand what are we trying to accomplish and not just collect for the sake of collecting or whatever. That's kind of what I took out of the presentation.
Yes.
Mm-hmm.
Make sure you're providing information for people and not just doing pretty graphs and charts.
Mm-hmm. Well, that's always the knock against data and analytics is great chart, great model, but does it make money? Does it work in the real world? Well, I don't know. It's a nice looking model and a great chart. So.
Yeah, but are people using it?
Exactly. All right, who do we have here?
Yeah, so anybody else?
Yeah, Linda, this is Prashant.
Hi, Prashant.
Yeah. So as you said in like step 3, so when you question to the customer and then you get answer for your while you build a matrix on that data. So how you rely on the customer's answer? So like if customer say something and you just process on those answer, or you just investigate further for how correct their answer.
And again, they're not giving the answers. What I'm asking them is, what do they need to know? What questions do they need answered? So I might ask a project manager, and he might give me answers. Let me see if I can go back over here.
I think in step 3 somewhere, I guess. Okay.
Yeah.
Yeah.
Oops.
Yeah.
Like here, he might say, I need to know whether I'm going to deliver on time. I said, okay, what do you need? And we'll brainstorm. I'll talk with them. I facilitate a session where I say, okay, what do you need to know? For example, they want to know whether their actual progress what is their actual progress towards completion. They want to know how much work they still have to do. So I'm working with them to find out what information they need, what questions they need answered. I'm asking them for the questions, not for the answers.
Oh, okay.
And then I go work with the metrics and come up with metrics to help provide data, information, and knowledge to answer those questions, the analytics, as it were.
Right.
So for example, what's our actual progress towards completion on this schedule? I might come up with something like an earned value metric, or I might come up with something that simply is a graph that shows what their plan was and have a line for their plan and then another line for their actual. And that would show them very graphically that are they on schedule or not. It's like a burn down chart for the agilists.
Right, yeah.
So if I'm looking at customer satisfaction, what's their current level of customer satisfaction? Well, you know, the metric may be some kind of data out of a satisfaction survey where we can show them areas that the customer cares about and how they scored on a scale of 1 to 5 or 1 to 10 in each of those areas. So we might come up with a graph that literally showed them, you know, they're a 5.8 in long-term reliability, but they're only a 3.2 in documentation. People hate their documentation.
Right.
Or whatever.
Oh, okay.
So we're getting them to tell us what the questions are, not what the answers are. We go find the answers in the data for them and answer their questions.
Oh, okay. Yeah, that's cool. Yeah.
So that's where we're picking the metrics. And then, of course, the rest of the process actually goes in and designs that metric for them, where what data they need to have, where they're going to pull it from, what equations they're going to use. What's the analytics on that? You know, is 10 too few? Is 100 too many? That all gets into the design of the metric, which is the rest of my software metrics class.
Right. Yeah.
This is just getting to the requirement. I need a metric that does this.
Yeah. Perfect. Yeah. That's nice. And what's the ivory tower approach?
Well, let me put it this way. There are billions and billions and billions of particles in our solar system that impact the gravitational pulls of our solar system. But when we're analyzing it and looking at that, what are the important factors? The sun, the planets. My husband says that the moons, this belt of matter out beyond Pluto. Nobody's going to include Halley's Comet in that combination.
Yeah, right.
You know, you don't want what is it? All models are wrong. Some models are useful. Box's quote. Is it good enough to provide you the information you need? Don't get ivory tower and try and consider every factor.
Everything, right? Yeah.
Look at the big important things. You can always include those smaller factors when you get down to measuring in millimeters. But if I want to decide whether to take a plane or a drive to San Francisco from Texas, to the nearest 100 miles to the nearest 1,000 miles is probably a good enough metric. So don't try and make them perfect.
Okay.
The example I always use, and this is because I'm a mathematician. So here's your one dirty joke of this webinar. I am a female mathematician. My degree is in theoretical math from Carnegie Mellon University. And as a mathematician, I can never reach the naked man standing in the door. Because first I have to get halfway there, and then halfway there, and then halfway there, and then halfway there. And there's an infinite number of halfway there's between the female mathematician and the naked man standing in the door. But as a female engineer, I can get close enough for all practical purposes. Right? So don't be a mathematician, be an engineer.
Engineer always,
Be practical and pragmatic. Get close enough for all practical purposes.
Yeah, thanks, Linda.
Thank you.
Yeah.
Where do we get tickets for your stand-up show, Linda?
That's my one joke. No,
I have a few.
I have a few, but My husband says my job is high-paid consultant and sit-down comedian. With my two bad knees, replaced knees, and a bad arthritic back, I sit, don't stand. But yeah, I'm not a stand-up comedian.
Sounds good.
Just to sit down.
Hey, we were talking before the show about, you know, where computers started, you know, toggle switches and so on. And now we're here. Keen to just get your thoughts and feelings on software development and the technology that's gone into that. What with, you know, I'm thinking about like the Atlassians and things like that, and Jira tools and all that. I mean, you've seen the whole evolution. Where is it going from here? What's going on with low code and programming, and how do you see that all coming together for the next 10 years or so?
Oh my gosh, what a question. It's hard to predict because predictions are always based on history.
Yeah.
And I mean, I've lived through a history of software, and I hadn't updated this slide. I've actually been in software for 45 years now. But we've come so far, it's hard to predict. You know, it's like we went smaller and smaller and smaller and smaller. At some point, we're going to reach a point where, I don't know, you plug it into your head and the computer has a human interface, and we can get away with talking directly to our computers. I'm just looking at an expanded, you know, big data today is going to look tiny in the future.
Yeah.
How's that sound?
Very, very believable. Yeah.
You know, I mean, I can remember the first time I had a meg of memory in a PC, and I thought I was set for life, that I would never need more than a meg of memory in any computer I ever used. And now I've got, you know, gigs of memory. It's just going so far, so fast. The new tools just amaze me. Although with artificial intelligence, I'm not sure we're there yet. Yeah. I actually talk in one of my classes about my car trying to kill me because it made a bad decision on the highway where I was passing a truck and it decided I got too close to the truck. I was like 3/4 of the way into the other lane, into a 2-lane highway, passing the truck. And I was still a good 2 or 3 car lengths away, but it decided I was too close, so it slammed on my brakes for me.
Right.
And I just about got rear-ended by the people that were coming up 70 miles an hour when all of a sudden I dropped to 40.
Exactly. Yeah.
You know, it's like, okay, I will not buy a car that hits my own. In fact, I just bought a car, and that was I told my husband, you can pick anything else you want, but it's not allowed to brake for you.
Right. Yeah. Yeah, I hear you. I spoke to a guy last year about machine learning and self-driving cars, and he's a PhD of machine learning working on these types of things. And I said, would you get in the car? And he goes, I'm not getting in one of those for years. Forget it.
It's not ready for prime time. I love the Internet of Things.
Mm-hmm.
I love being able to upgrade equipment and things but hey, I moved to a new house a couple of years ago. The air conditioning had to be replaced. Mm-hmm. My air conditioning is talking on the internet.
Right.
The washer and dryer talk on the internet. And of course, my first request is turn it all off.
Yeah.
Please turn it all off, disconnect it, do not hook it up. You know, it's great if I want to upgrade, I'll plug it back in long enough to upgrade. But I worry that if I go out of town, somebody will see that my temperature in my house has been turned low and know I'm not home and come rob me because they hack in. Sometimes I think we've gotten ahead of ourselves.
Yeah.
But then on the other hand, my husband had heart surgery with a Da Vinci machine, and they were able to repair a heart valve without doing open heart surgery.
Right.
And I go, what a miracle.
Mm-hmm. Mm-hmm.
I mean, his hospital stay went from a month or more to less than a week.
Right.
His recovery time, the amount of pain he had, et cetera, et cetera, et cetera. So what they're doing is phenomenal. It's just science fiction from when I grew up.
Oh, completely.
Completely.
Yeah.
So my vision of the future is bright and cheerful, but we need to make sure we don't get ahead of ourselves. that we don't try and use it before it's ready for prime time.
Mhm.
Back in the day, I used to have a mug that said, to err is human, to really foul things up requires a computer.
Yeah.
Because back then you were lucky if you could get, 70, 80% defect removal effectiveness before you ship the product. The technologies just weren't there yet.
Mhm.
Today, world class is they're finding 89% of defects before. The quality is so much better. The
Mhm.
abilities, the performance, the usability. We were talking when I started, I'm from the DOS generation. You used to see a green screen with a little greater than sign, and that was it. And then you had to have memorized all the commands, and you had to be a computer programmer just to use one of those things.
Right, right.
And now my 12-year, my nephew went to a computer magnet school for kindergarten.
Mhm. Yeah, exactly.
So it's just phenomenal. And I think that the advantage of software, it is not restricted by the physical universe like hardware is.
Right.
If you can imagine it, you can do it in software. And people's imagination is unbounded. So I
Mhm.
think we've got a very bright future. Sometimes I want to say, yeah, but take a little caution. Let's do a little risk management here. Let's do a
Yeah.
little safety analysis before we go do this.
Yeah, you really need to appeal to the ethics of the whole thing, I think.
Yeah, and the laws haven't even begun to keep up with the computer age, things like that.
Have you had the pleasure of listening to those Senate or Congress grillings of Zuckerberg and Darcy or Dempsey or whatever his name is? Have you seen any of that?
I have seen none of it. I decided about 3 years ago that the news and television was stressing me out.
Yeah.
I turned it off and haven't watched it since.
Oh, well, no wonder you're in such a good mood.
I don't. My husband if there's anything important going on, my husband will tell me about it. But no, I just decide, I'm one of these people that I spend my free time watching tutorials, webinars, classes on software engineering, reading books.
Yeah.
I'll just see if I can show you. Well, I'm knocking things
geez.
over here. There's my library of software engineering books.
Whoa. Great. Do you have a favorite language? Like, are you like Java all the way or Python or anything?
I have not programmed since those came out.
Well, nothing else has come out since.
Yeah, but well, I'm saying back in my programming days, I was programming in Fortran, PL1, and assembly language. And I still favor assembly language because I'm a control freak. And I love to have ultimate control of every single register and every single bit. But then I'm doing real-time, what I was doing was real-time software engineering control systems, where we were controlling hardware down to that level. So I still love assembly language, but it's been a long time since I programmed.
Gotcha.
The last language I programmed in was SQL, extracting data from databases.
Yep. Very good. Well, Amin?
Yeah, let's wind up. Thank you for sharing tons of knowledge today, not just about how to select, useful matrices, but, tons of knowledge apart from that as well. So yeah, thank you so much, Linda, for today. And thank you everyone for joining in.
Yeah, thank you for inviting me. I love to share my knowledge. And I'll reiterate one more time, I love to talk to people about this. So if you have any questions as you go try and apply anything that I've talked about here today, please feel free to shoot me an email. That's usually the best way to get a hold of me.
Will do. Thank you.
Thank you, Linda. It was a great presentation. Thanks.
Thank you.
All right. See you later.